Yeah, good evening. Can you hear me? Anyone, please unmute yourself.
Yes, sir.
We can hear you, sir.
Okay, fine, fine. Okay, so let's go ahead. The common instruction is if my I will share the screen also. So if my voice is not clearly audible and if my screen is not clearly visible, okay, so please unmute yourself and please inform me immediately so that the corrective measure can be taken.
Yes,
Otherwise, in the online mode, it's very difficult to understand whether you are getting proper audio and video quality. Is it okay?
yes, sir.
Yes,
Sir,
sir.
I wanted to ask the ISE portion.
Yes, yes, Arnav.
Yes, sir. Oh, ISE का portion that I wanted to ask.
Yes, yes. So I've already sent the IAS scheme, na. So along with IAS scheme, the IAS syllabus is there. So syllabus for IAS is module 1 and module 2.
Okay, sir. Thank you, sir.
Okay.
Okay.
Yeah. So let's start. So
Yes,
already we have finished module 1. Just a few things we have to discuss in. We will solve a few more numericals on vehicle vibration and single degree of freedom. So we have already finished module 1, and then we will discuss the remaining portion of module 2 also. Okay, so we will be able to finish the entire syllabus for IAC in today's class, or maybe if few things left, then we will finish it on Monday. Okay, and in fact you can discuss on Monday about we will discuss regarding that how to prepare for IAC also. So that discussion also will take on Monday, offline lecture in college. Okay. So everything will be done by today itself. Okay. As far as the ISC syllabus is concerned. So we'll be able to finish entire syllabus by today in today's class. Okay. So I'm going to share the screen. Okay. Yes, can you see my screen properly?
Yes, sir.
Okay. Okay. So we had solved this problem last time. Now this is the problem we have to solve. Okay. So I'm providing you 2 minutes. Okay, solve this problem. Determine the time in which the mass in a damped vibrating system would settle down to 1/50th of its initial deflection for the following data. The mass is given as 200 kg. Epsilon is 0.22, that is the damping factor is 0.22, and S, that means the spring stiffness is 40 Newton per mm. Okay, so we have to find the time and also find the number of oscillation completed to reach this value of deflection. Okay, so take 2 minutes and okay, so try to solve this problem. Okay, and then we'll discuss the approach and then we'll go ahead together. Okay. So what is the approach? Here we have to find the time and the number of oscillations. Okay. So let's go ahead. Yes, you can hear me properly, na?
Yes, sir.
Okay, okay, fine. Thanks. Okay. So let's see how to solve this problem. So basically, we know the ratio of the amplitudes is this ratio of two amplitudes x naught by xn, x naught by xn is equal to, what is the formula? E to the power epsilon omega n into n and into td. This is the mathematical expression for the ratio, for the calculating the ratio of two amplitudes. Okay, now let's see. So omega n in this expression, so we have to find omega n. Okay, so this is the mathematical expression. Now let's see how to calculate omega n. We know the formula. We know how to calculate omega n. If the spring constant is there, okay, if the spring constant is there and the mass is there, so omega n is equal to square root s by m. Okay, so this omega n is equal to square root s by m. Okay, the value is given, the stiffness value is given, spring stiffness value, this is given 40 Newton per meter, and the mass is also given. So put the value here in this expression. So you can calculate this natural frequency. So tell me what is the value of this natural frequency? है ना, कितना है ये? 40 Newton per mm. Okay, so per mm you convert this in meters, so 10 to power minus 3 meters in denominator, so 10 to power minus 3 numerator में जाएगा to 10 to the power 3, that means 40 into 1000 Newton per meter. Okay, 40 into 1000 Newton per meter, and the mass is 200. So you can calculate omega n value. So calculated value of omega n is 14.14. What is the unit of omega n? Radian per second. Okay, this is the unit. Now we have calculated this omega n. The epsilon value is given, n value that we need to find, and td we have to, this is also required, td. Okay, so this is also required. So we'll see how to calculate this. So you just, so ntd is unknown, so we'll put the value. Okay, so what is this x naught by xn? Here it is given, determine the time in which the mass is in a damped vibrating system would settle down to 1 by 50th of its initial deflection for the following data. 1 by 50th, that means 1 divided by 1 by 50th, that means 1 divided by 1 by 50, that means it is 50 only. Okay, let's do this. So it is 50, it is equal to e to the power epsilon value is given as 0.22. It is given in the problem. And omega n we have just calculated, it is 14.14, and this n is unknown and td is unknown. So just take the antilog and we can find the value from this, the value of ntd. Okay, so you can find the value of ntd. ntd कितना आ गया? antilog लेने के बाद it is 1.26. What will be the unit? This is a time, so the unit will be seconds. Okay, so from this we can find this. So how can we find this uh, TD? Let's see this, how to find this TD. What is the formula for calculating TD? TD is equal to 2 pi by omega d. Okay, and what is omega d? The formula for calculating this damped frequency is square root 1 minus epsilon square into omega n. So it is equal, put the values, 2 pi square root 1 minus epsilon is 0.22 स्क्वायर, ठीक है। और ओमेगा एन क्या है? ओमेगा एन इज 14 पॉइंट, okay, multiplied by 14.14. So in this way we can calculate TD. So calculated value of TD is 0.455 seconds. Now you put the value here in the above expression, you put the value in this equation. So you can see n into the TD is 0.455 is equal to 1.26. So from this we can find the value of n. The calculated value of n is 2.76. So this is our answer. So this is how we have determined the number of oscillations completed to reach this value of deflection. This was asked, right? So we have to determine the time in which the mass in a damped vibrating system would settle down to 1 by 50th of its initial deflection. So we have determined this time value. Okay, this time value, time period, and then after this we have determined the number of oscillations completed to reach this value of deflection. This. Okay, so this is the answer. N is equal to 2.76. Right?
Yes, sir.
Okay. So चलिए अब नेक्स्ट प्रॉब्लम सॉल्व करेंगे. Do this. In a single degree damped vibrating system, a suspended mass of 8 kg makes 30 oscillations in 18 seconds. Now the amplitude decreases to 0.25 of the initial value after 5 oscillations. Now we have to determine all this: the stiffness of the spring, logarithmic decrement, damping factor, and the damping coefficient. We have to determine all this. So do this and tell me. Just take 1 minute. Okay, so let's solve this problem. First of all, we'll find that first one. Okay. What is the first one? The stiffness of the spring. So okay, so let me write what is given in the problem. Okay, so what is given? क्या दिया है?
Sir, mass is 8 kg, which
Yes,
makes oscillations 30, and time is
बिल्कुल.
18 seconds.
Yes, mass is 8 kg. Okay, and
सर
oscillations
वो जो
हमको दिए.
स्टेटमेंट है ना, द एम्पलीट्यूड डिक्रीजेस टू 0.25, तो सर वो फाइनल एम्पलीट्यूड ही कंसिडर किया जाएगा ना,
हाँ, अभी उसका उसका
वैलिड
देखते
एट
हैं.
टाइम जो गिवन है
हाँ हाँ
क्वेश्चन में।
हाँ हाँ, नहीं नहीं, अभी उसका देखते हैं ना, उसमें कि लैंग्वेज के कैसे यूज करना है. दैट इज इम्पोर्टेंट वन. ओके, आप आपने क्या बोला?
यस
दैट इज डिक्रीजेस टू, जस्ट टेल मी.
सर, फाइनल एम्पलीट्यूड जो होगा वो 0.25 होगा।
0.25. So
नो नो सर, वेट
actually
वेट,
x5 is
एम्पलीट्यूड
0.25.
डिक्रीजेस टू 0.25।
समझे आप? x0 को अगर 1 लेंगे तो x5 जो है वो 0.25 रहेगा,
हाँ,
है ना?
यस सर।
हम्म.
तो सर, जो फाइनल एम्पलीट्यूड होगा वो इनिशियल एम्पलीट्यूड के 0.25 टाइम्स होगा ना, मतलब 5
हाँ
ऑसिलेशन के बाद।
हाँ, करेक्ट. x0 1 है तो x5 0.25 होगा.
हाँ, ओके गॉट इट।
ठीक है. हाँ, यही समझने वाली बात है. गुड. तो अभी n देखो, नंबर ऑफ ऑसिलेशंस कितना दिया हुआ है? 30. ओके, और क्या दिया है? टाइम पीरियड दिया है अपने को. टाइम इज 18 सेकंड. सो लेट्स डू दिस वन बाय वन. ठीक है. तो सबसे पहले हम लोग फाइंड करेंगे स्टिफनेस ऑफ द स्प्रिंग. नंबर वन वी विल डू इट फर्स्ट. चलो यहीं पर करते हैं फर्स्ट वन. यहाँ पे हमने सॉल्व किया तो सबसे पहले देखो क्या है. What is this? The 30 oscillation in 18 seconds. So what will be the linear velocity? Sorry, what will be the linear frequency? Linear frequency will be equal to number of oscillations divided by time. Okay, that means 30 divided by 18. In this way, I can find linear frequency. So it is 1.67. Linear frequency का unit क्या होता है? Hertz. Okay, 1.67 hertz. Now, how can I find the circular frequency or the natural frequency? The formula is 2 pi into linear frequency, 2 pi fn. Okay, 2 pi into linear frequency. So it will be 2 pi into 1.67. The calculated value is 10.47. And what is the unit of the circular frequency or the natural frequency? Radian per second. Okay, so we have calculated omega n also. Now we have done this. Now omega n, what is the formula? We have to find the stiffness of the spring. Omega n is equal to square root s by m. So from this I know the value of omega n, that is 10.47. It is equal to square root s. I need to find the stiffness of the spring. The mass is given as 8 kg. Just solve this. So from this we can find the value of s. So calculated value of s is 877 Newton per meter. ओके. और अगर मैं इसको लिखूं न्यूटन पर एमएम में, तो देखो मीटर से कन्वर्ट करने में एमएम में 1000. ओके, मल्टीप्लाई बाय 1000 इन द डिनोमिनेटर. तो अभी न्यूमरेटर में लेके जाएंगे तो दैट मीन्स मल्टीप्लाई बाय 10 to the power -3.
10 की पावर -3, हाँ।
यस, है ना? तो ये आपका आंसर हो जाएगा 0.877 न्यूटन पर एमएम. तो दिस इज द आंसर. ठीक है, तो नंबर वन डन. नाउ लेट्स सॉल्व लॉगरिथमिक डिक्रीमेंट. लॉगरिथमिक डिक्रीमेंट कीजिए. सॉल्व. ओके, सो सेकंड वन चलिए सॉल्व करेंगे। अब देखो यहाँ पे समझने वाली बात है, x0 बाय x5, ये जो मैंने कंसेप्ट पढ़ाया था तब ये एक्सप्लेन किया था, है ना। x0 बाय x5 को कैसे लिख सकते हैं, x0 बाय x1, 1 मिनट मैं रब करता हूँ, ओके, x0 बाय x5 इज इक्वल x0 बाय x1 into x1 by x2 into x2 by x3 into x3 by x4 into x4 by x5. Okay, and
यस सर।
since we know all the ratios are equal, हमें मालूम है रेशियो जो है वो इक्वल होते हैं, x0 by x1 is equal to x1 by x2 is equal to x2 by x3 is equal to x3 by x4 is equal to x4 by x5। ये सभी रेशियोज जो होते हैं ये बराबर होते हैं। ठीक है, ठीक है ना। x0 बाय x5 को ऐसे लिख सकते हैं, x0 बाय x1 इंटू x1 बाय x2 इंटू x2 बाय x3 इंटू x3 बाय x4 इंटू x4 बाय x5। ये देखो x1 x1 कट जाएगा, x2 x2 x3 x3 x4 x4 सब कैंसिल हो जाएगा, x0 बाय x5 बचेगा और ये सभी रेशियोज बराबर होते हैं। तो फाइनली व्हाट कैन आई राइट, आई कैन राइट x0 बाय x5 is equal to x0 by x1 to the power 5, करेक्ट। ठीक है ना, x0 by x1 to the power
सर
5।
एक्स जीरो था। सर एक्स जीरो बाई एक्स वन कैसा है इसमें इंटू पावर फाइव कर दें।
ये बराबर है ना, हम ये देखो हमने पांचों रेशियो है, x0 by x1 है, इस ये भी x0 by x1, 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 ये बराबर है ना रेशियो।
हाँ सर वो ठीक है, लेकिन सर इसमें जो है ना ये जो सिंस वाला टर्म है उसमें आपने लिखा है एक्स जीरो एक्स वन इज इक्वल टू जो सबसे है ना लास्ट में एक्स फोर बाई एक्स फाइव,
हाँ,
वो है ना सर, तो ये एक्स जीरो बाई एक्स फाइव कैसे आया।
नहीं नहीं, वो आप कुछ भी लिख सकते हो, दीज रेशियोज आर इक्वल।
अच्छा ओके।
हाँ
अच्छा
मैं
मतलब एक्स वन एक्स टू
हाँ
एक्स थ्री एक्स फोर एक्स फाइव सब सेम है।
हाँ सब सेम है ना, देखो रेशियो सेम है ना, x0 by x1 इज इक्वल x1 by x2 इज इक्वल x2 by x3 इज इक्वल x3 by x4 इज इक्वल x4 by x5। अब देखो ये x0 और x5 के टर्म्स में है, इसलिए मुझे x0 वाला टर्म्स में चाहिए फर्स्ट रेशियो के टर्म में। मैं इसको ये भी लिख सकता हूँ x1 by x2 to the power 5, इसको मैं लिख सकता हूँ x2 by x3 to the power 5, x3 by x4 to the power 5, x4 by x5 to the power 5, क्योंकि क्या है ये सब ये रेशियो बराबर है ना,
हाँ
समझ में आया ना।
यस सर।
हाँ चलो, अब इसमें हम क्या लिख सकते हैं, हमें हम लिख सकते हैं x अल्टीमेटली आई नीड टू कैलकुलेट x0 बाय x1, आई एम इंटरेस्टेड इन दिस, इसलिए मैंने इसमें लिखा। ठीक है, तो x0 बाय x1 क्या हो जाएगा, इट इज इक्वल टू x0 बाय x5 टू द पावर 1 by 5। इज इट ओके और नॉट, x0 by x1 is equal to x0 by x5 to the power 1 by 5।
हाँ
और
हाँ
ये क्या है ना, x0 क्या है, x0 1 है, तो अपना x5 क्या है, देखो ये दिया हुआ है प्रॉब्लम में, the amplitude decreases to 0.25 of the initial value after 5 oscillation। तो इनिशियल वैल्यू अगर 1 है तो ये कितनी हो गई, 0.25 5 ऑसिलेशंस के बाद, 5 ऑसिलेशन इसलिए x5 लिया था हमने, 0.25 टू द पावर 1 by 5। ठीक है, तो अपना x0 by x1 क्या आ गया, 1.32, ये आ गया अपना 1.32। अब लॉगरिथमिक डिक्रीमेंट क्या हो जाएगा, मैं यहाँ पर ही लिखता हूँ, स्पेस है ना, चलो ये नीचे लिख देंगे, चलो। So what is the delta? Delta is the logarithmic decrement. It is the natural logarithmic of this amplitude ratio. Natural logarithmic of this amplitude ratio. So it is natural logarithmic of 1.32. So the answer is 0.278. So this is the answer. This is the logarithmic decrement. So we have calculated logarithmic decrement also. Now let's calculate damping factor. Yes, वकार समझ में आया?
यस सर आप
चलो अब डैम्पिंग फैक्टर करो। ये तो बिल्कुल स्ट्रेट फॉरवर्ड है डैम्पिंग फैक्टर। The formula, we know the formula for calculating the logarithmic decrement in terms of damping factor, and the damping factor is only unknown. That's it. And logarithmic decrement we have already calculated. So from that we can easily calculate this, है ना? कोई प्रॉब्लम ही नहीं है। चलो तो तीसरा वाला अभी कर लेते हैं हम लोग। थर्ड जो है, हाँ चलो यहीं पे ही करते हैं थर्ड। आई विल यूज सम डिफरेंट कलर so that you can, things will be easy. Okay, है ना? Space is limited, so I'm writing third one here. Okay, about this next problem. So the third one, okay, so what is the formula for the delta, the logarithmic decrement? The formula for calculating logarithmic decrement is 2 pi epsilon square root of 1 minus epsilon square. So from this, I know the value of delta, just put the value 0.278 is equal to 2 pi epsilon square root of 1 minus epsilon square. So we have one equation and one unknown, that is epsilon. Just solve this so you can find the value of epsilon. The calculated value of epsilon is 0.0442. So this is how we can calculate damping factor. ठीक है, damping factor भी हो गया। ओके, चलिए। Now the next one, last one, the damping coefficient. So let's calculate, ना, तो ये भी हो गया आपका। अब हम कैलकुलेट करेंगे द डैम्पिंग कोफिशिएंट। लेट्स डू दिस। So fourth one, the damping coefficient, and I am solving here at the top.
सर एक सेकंड वो पार्ट नंबर थर्ड पे स्लाइड शिफ्ट करो ना, वो मैं थोड़ा लिख रहा था।
अच्छा, थर्ड वन,
हाँ थर्ड वाला
हाँ ये लिख।
डैम्पिंग फैक्टर वाला।
हम्म,
हो गया सर डन।
done. Okay, now let's solve the fourth one, the last one, the damping coefficient. Okay, so straightforward formula is there. Okay, so very simple to calculate, है ना? I've told you to calculate how to calculate damping coefficient. I have given 3 to 4 formulas, and out of these uh, 3 formulas, you can use any one as per requirement and the availability of the parameters what is given in the problem. Okay, so C is equal to 2m omega n epsilon. That's it. Done. Everything is given. So 2 into mass is what? 8 kg. Epsilon n, I've already calculated this. This is 10.47. Okay. And what is the value of epsilon? Epsilon just calculated, है ना, कहाँ ये
जीरो
रहा?
पॉइंट जीरो डबल फोर टू
Yes, 0.0442. That's it. We just solve this. तो C का वैल्यू आ गया 7.4 Newton per meter per second. So this is the answer. Okay, so we have calculated all the four. Okay, so such type of problems are already asked number of times in the exam. Okay, so understood na?
यस सर
Okay, चलिए अब हम लोग ये सॉल्व करेंगे प्रॉब्लम. लेट्स सॉल्व द अनदर वन. A machine mounted on springs and fitted with a dashpot has a mass of 60 kg. There are three springs, each having stiffness 12 Newton per mm. The amplitude of vibration reduces from 45 to 8 mm in two complete oscillations. Assuming that the damping force varies as the velocity, now we have to determine three things. First one is the damping coefficient, second one the ratio of the frequency of the damped and undamped vibration, and the time and the periodic time of the damped vibration. This we have to calculate. Okay, so think over it. I am providing you 1 minute. Okay, and then we'll solve this problem together. Okay. Okay, so let's see. Yes, can you hear me?
यस सर
Okay. चलिए सॉल्व करते हैं. Now, okay, so number one, we have to solve first. That is the damping coefficient. This we need to find. Epsilon हमें find करना है. ठीक है. तो अब आप देखो क्या क्या दिया हुआ है. मास दिया हुआ है, स्टिफनेस दिया हुआ है, और एम्पलीट्यूड कैसे रिड्यूस हो रहा है वो दिया है. टू ऑसिलेशंस. टू ऑसिलेशन है यानी कहां तक जाएगा. लास्ट टाइम 5 ऑसिलेशन थे तो हम कहां तक गए थे, x5 तक. टू ऑसिलेशन तो कहां तक जाएगा.
सर x2
यस, दैट्स इट. जितने ऑसिलेशंस दिए हुए उस हिसाब से करेंगे. 10 ऑसिलेशन तो x10 तक जाते, है ना. तो लेट्स सी. So the mass is given. So mass is 60 kg. Okay, mass is given as 60 kg. Stiffness is given as 12 Newton per mm. Okay, तो यही है ना. ये क्या है, ईच की देखो 3 springs हैं. You can see here 3 springs are there and each having stiffness 12 Newton per mm. तो अभी देखो एक का स्टिफनेस 12 न्यूटन पर एमएम है, टोटल 3 स्प्रिंग है. तो कंबाइंड स्टिफनेस क्या हो जाएगा.
36
यस, वेरी गुड, वेरी गुड, है ना. तो कंबाइंड स्टिफनेस विल बी इक्वल टू 3 इंटू 12. ओके, इट इज इक्वल टू 36, है ना। अब मेरे को न्यूटन पर एमएम में करना, तो एमएम से मीटर में कन्वर्ट किया तो 10⁻³ विल बी इन द डिनोमिनेटर, और 10⁻³ न्यूमरेटर में आएगा तो 10⁻³ 10⁻³ का मल्टीप्लाई हो जाएगा इन द न्यूमरेटर, 10⁻³ न्यूटन पर मीटर। सो ये हमारा कंबाइंड स्टिफनेस आ गया, ठीक है। अब हम ओमेगा एन कैलकुलेट करेंगे। ओमेगा एन इज इक्वल टू व्हाट, तो फॉर्मूला इज स्क्वायर रूट एस बाय एम, तो इट इज इक्वल टू स्क्वायर रूट एस क्या है 36 इंटू 10⁻³ एंड मास इज 60, तो जस्ट कैलकुलेट दिस। सो ओमेगा एन अपना आ गया 24.49 रेडियन पर सेकंड। ओके, नाउ लेट्स सी, so x0 by x2, I can write x0 by x2 is equal to, कैसे लिखेंगे लास्ट टाइम की तरह लिखेंगे, x0 by x1 into x1 by x2, and since we know this ratio x0 by x1 is equal to x1 by x2, ये दोनों रेशियो बराबर हैं, ठीक है। तो फाइनली मैं क्या लिखूंगा, I can write x0 by x2 is equal to x0 by x1 होल स्क्वायर। तो यहां से मुझे x0 by x1 क्या मिल जाएगा, x0 by x1 इज इक्वल टू x0 by x2 टू द पावर 1/2, सही है ना।
यस सर।
अब x0 by x2 क्या हो जाएगा, अब इस लैंग्वेज से देखो, द एम्पलीट्यूड ऑफ द वाइब्रेशन रिड्यूसेस फ्रॉम 45 to 8, यानी रेशियो क्या हो गया 45 डिवाइडेड बाय 8। ओके, समवन इज ज्वाइंड। ओके ओके, तो अभी देखो, ठीक है ना। तो अभी करो भाई, फॉर ये क्या दिया हुआ है 45 to 8, एम्पलीट्यूड ऑफ वाइब्रेशन रिड्यूसर फ्रॉम 45 to 8। तो अभी विल पुट द वैल्यूज हियर, 45 डिवाइडेड बाय 8 टू द पावर 1/2, इससे अपना x0 by x1 क्या आ गया,
सर 2.37।
यस वेरी गुड, 2.37, दिस इज द कैलकुलेटेड वैल्यू, गुड, ठीक है। सो नाउ वी विल कैलकुलेट दिस डेल्टा, जैसे पहले किया था ना। अभी देखो ये आ गया अपना रेशियो, इसका डेल्टा कैलकुलेट कर लो। डेल्टा क्या है, लॉगरिथमिक डिक्रीमेंट है, फटाफट कर लो लॉगरिथमिक डिक्रीमेंट। तो लॉगरिथमिक डिक्रीमेंट अपना क्या हो गया, डेल्टा इज इक्वल टू नेचुरल लॉग ऑफ दिस एम्पलीट्यूड रेशियो, दैट इज नेचुरल लॉग ऑफ 2.37, क्या आ रहा है आंसर, .864 आ रहा है।
हाँ यस सर 0.864।
ओके, ठीक है। अब हमें डेल्टा का फॉर्मूला मालूम है, डेल्टा इज इक्वल टू 2 पाई एप्सिलॉन divided by square root of 1 minus epsilon square, and you just put the value of delta here, ये डेल्टा का वैल्यू है यहाँ पे पुट कर दो, यहाँ से you will get one equation, one unknown, that is epsilon. So epsilon value you can find, the calculated value of epsilon is 0.136, 0.136. Okay, so we have calculated this. Okay, this damping factor, that is unitless. Okay, we know this, the damping coefficient, that is epsilon, that is 0.136. So done, first one we have solved. Okay, now let's work for the second one. भाई am I right or not? Whether I have determined first one or not? The question mark for you. Yes, Vakar?
सर एक सेकंड में।
हाँ. Yes, Jaden?
नहीं वो
यस सर।
सर
हाँ.
आई गेस इसमें सी कैलकुलेट करना है ना अभी।
Yes, yes, yes. Very good.
तो
Excellent.
2m ओमेगा एन एप्सिलॉन
हाँ,
यूज होगा।
करेक्ट करेक्ट, यही मैं एप्सिलॉन को सुनना चाह रही, आइडेंटिफाई होना चाहिए। एप्सिलॉन क्या है? डैम्पिंग फैक्टर है ना?
हाँ वही।
और डैम्पिंग कोफिशिएंट पूछा गया है, तो डैम्पिंग कोफिशिएंट होता है सी। वेरी गुड, है ना? तो सी कैलकुलेट करो अभी। ये सरनब समझ में आ रहा है ना? ये सरनब?
यस सर, समझ में आ रहा है सर।
ओके
वो लिख रहा था मैं, सॉरी।
ओके ओके, फाइन फाइन। सो लिखिए, सी का वैल्यू लिखिए। सी इज इक्वल टू 2m ओमेगा एन एप्सिलॉन, दैट्स इट। दिस इज डैम्पिंग कोफिशिएंट। सो 2 इंटू मास कितना है? मास अपने को 60 दिया हुआ है। ओमेगा एन है ना, देख लेते हैं वैल्यू। मास इज 60 केजी, करेक्ट। ओमेगा एन कितना था ये हमने कैलकुलेट कर लिया है, 24.49। ठीक है, और एप्सिलॉन वैल्यू तो कैलकुलेट किया ही है, ये रहा। ठीक है, तो वैल्यू, पुट द वैल्यूज। सो इट इज 24.49 into 0.136. Okay, that's it. So just calculate this.
सर 399.68 आ रहा है।
399
68।
Okay, okay. That means approximately 400. Correct answer. 400 न्यूटन पर मीटर पर सेकंड, एंड सो दिस इज इक्वल टू, अगर एमएम में करना चाहें तो, अब एमएम में करना है आपको तो 10⁻³ का मल्टीप्लाई होगा डिनोमिनेटर में, और डिनोमिनेटर से फिर वो 10⁻³ को हम न्यूमरेटर में लेके जाएंगे, 10⁻³ हो जाएगा। तो 400 इंटू 10⁻³ दैट मींस इट इज 0.4 न्यूटन पर एमएम पर सेकंड। दिस इज द आंसर। ठीक है, तो ये अपना आंसर हो गया सी का। तो अब फुलफिल हुआ पहला वाला, डैम्पिंग कोफिशिएंट। ठीक है, तो उसमें डैम्पिंग फैक्टर अगर पूछा है तो एप्सिलॉन तक कैलकुलेट करेंगे, अगर डैम्पिंग कोफिशिएंट पूछा है तो सी कैलकुलेट कर लिया। ठीक है, नाउ लेट्स गो अहेड द सेकंड वन। सेकंड वन बताइए फटाफट। यस जीदन, कैसे करेंगे कैलकुलेट सेकंड वाला?
एक मिनट सर।
मैं थोड़ा स्पेस तो अभी भर गया है इधर, लेट्स सी। है ना, उधर हम लोगों ने ऑलरेडी सॉल्व द प्रॉब्लम। अब ओके, साइड में करेंगे। तो कुछ डिफरेंट कलर लेता हूं मैं। ओके, पर्पल वन है, चलो। ओके सो डू दिस। क्या किया जाए? हम्म, चलो मैं ना ये पर्पल से कर रहा हूँ सेकंड वन ना। तो चलो इधर में साइड में स्पेस बनाया है मैंने। लेट्स सी, 1 मिनट प्लीज, आई विल यूज अबव। हाँ, चलो यहाँ पे लिखेंगे। क्या है ये, क्या पूछ रहा है? रेशियो ऑफ फ्रीक्वेंसी ऑफ डैम्ड एंड अनडैम्ड वाइब्रेशन, यानी क्या पूछ रहा है ये? डैम्ड एंड अनडैम्ड। डैम्ड फ्रीक्वेंसी क्या होता है? ओमेगा डी। और अनडैम्ड क्या होता है? ओमेगा एन। दैट्स इट, खत्म हो गया ना। तो इसका फॉर्मूला क्या होता है? ओमेगा डी का फॉर्मूला क्या होता है जिदन? square root
Yes,
1
sir.
minus epsilon square into omega n
Whenever, yes, sir.
divided by ओमेगा, और ओमेगा n तो ओमेगा n है ही,
Hmm.
बस। ठीक है ना,
Yes,
ये
sir.
हमें फाइंड करना था। ओमेगा एन कैंसिल आउट, दैट्स इट। तो ओमेगा डी बाय ओमेगा एन क्या हो गया, स्क्वायर रूट ऑफ 1 माइनस एप्सिलॉन स्क्वायर, है ना। ओमेगा डी बाय ओमेगा एन आपका आ गया स्क्वायर रूट ऑफ 1 माइनस एप्सिलॉन स्क्वायर।
Epsilon and
तो
epsilon
एप्सिलॉन
square.
का
Yes.
हमने वैल्यू कैलकुलेट किया हुआ था, क्या था वैल्यू एप्सिलॉन, 0.136, स्क्वायर रूट 1 माइनस 0.136। तो आंसर इज 0.99। यूनिट क्या होगा, नो यूनिट, सिंस इट इज रेशियो ऑफ टू फ्रीक्वेंसी। 0.99, दिस इज द आंसर, सेकंड वन। ओके, मैं यहां पर लिख रहा हूं सेकंड वन। ओके, सो दिस इज द आंसर 0.99। ठीक है, अब चलो थर्ड वन करेंगे। थर्ड वन, दैट इज द टाइम पीरियड। ओके, आई विल यूज सम डिफरेंट कलर नाउ, ग्रीन वन। ओके, थर्ड के लिए चलो तीसरा वाला करेंगे। टाइम पीरियड क्या करें पकार,
Yes, sir.
टाइम पीरियड कैलकुलेट करना है,
हम्म,
बिल्कुल स्ट्रेट फॉरवर्ड है।
हाँ,
टीडी का फॉर्मूला क्या होता है, टीडी इज इक्वल टू 2 पाई बाय ओमेगा डी। yes, whatever I am writing, you can see na, td is equal to 2 pi by omega d।
yes,
Yes,
sir.
sir.
ओके फाइन, चलो अब क्या करना है अपने को, 2 पाई ओमेगा डी क्या है, स्क्वायर रूट 1 माइनस एप्सिलॉन स्क्वायर इनटू ओमेगा एन। अब कर लो, अब क्या बस जस्ट पुट द वैल्यूज, दैट्स इट, वेरी सिंपल, है ना। पुट द वैल्यूज, तो 2 पाई, अब एप्सिलॉन का वैल्यू क्या दिया हुआ है, 1 माइनस 0.136, इसका स्क्वायर हो गया स्क्वायर रूट में। ठीक है, और यहाँ पर बाहर में लेके अपना ओमेगा एन का वैल्यू रख दो। ओमेगा एन हमने कैलकुलेट किया था, कितना है तो ओमेगा एन ये रहा 24.49, तो मल्टीप्लाइड बाय 24.49, दैट्स इट। तो टाइम पीरियड का फॉर्मूला क्या आ गया, हाँ टाइम पीरियड कैलकुलेटेड, टाइम पीरियड वैल्यू क्या आ गया, 0.259, what will be the unit, it since it is time period, so unit is second, so this is the answer। okay, so we have calculated this also। तो हमने इस प्रॉब्लम में डैम्पिंग कोफिशिएंट कैलकुलेट किया, है ना, रेशियो ऑफ फ्रीक्वेंसी ऑफ डैम्ड एंड अनडैम्ड वाइब्रेशन कैलकुलेट किया, एंड पीरियोडिक टाइम ऑफ डैम्ड वाइब्रेशन, दिस वी हैव कैलकुलेटेड, डन।
yes, sir. सर ये सेकंड पार्ट में एक डाउट था, जब
हाँ,
ओमेगा एन को कैंसिल ही करना है तो उसको फॉर्मूला में इंक्लूड क्यों किया?
नहीं नहीं, क्या पूछा है, रेशियो ऑफ
ये
फ्रीक्वेंसी
जो,
ऑफ
हाँ,
डैम्ड एंड अनडैम्ड वाइब्रेशन, सो वी हैव टू कैलकुलेट ओमेगा डी डिवाइड बाय ओमेगा एन। ठीक है ना, and what is the formula for
हाँ,
calculating omega d, the formula for calculating omega d is square root 1 minus epsilon square into omega n। तो
अच्छा,
नीचे
ओके,
ओमेगा
वैसे
n है,
ठीक है, ठीक
हाँ, ओमेगा एन
है, हाँ,
कैंसिल हो
अच्छा,
जाएगा, तो केवल स्क्वायर रूट 1 माइनस एप्सिलॉन स्क्वायर बचेगा।
ओके सर, थैंक यू।
हाँ, ठीक है, तो दिस these are the problems। okay, so this is how and after this है ना, the problems are there on the vehicle vibration in 2 degree of freedom, ये सब तो हमने कल वाले लेक्चर में सब सॉल्व कर लिया है ना, ये सब प्रॉब्लम्स, है ना, these problems, so already finished all these problems। okay, so this is how we have completed। okay, so we have completed module 1 complete in all respect। okay, नाउ वी विल मूव टू मॉड्यूल 2. मॉड्यूल 2 में भी हमारा ना आधे से ज्यादा मॉड्यूल 2 भी हो गया है. जस्ट थोड़ा सा कुछ कंसेप्ट्स हैं वो आई विल डिस्कस. Okay, and then we will be able to finish that module 2 also ना. 60%, 60 to 65% of the module 2 is also over, है ना. हम बस थोड़ा और जो कंक्लूडिंग पार्ट है, रिमेनिंग पार्ट, सो वो और देख लेते हैं मॉड्यूल 2 टायर्स का. So we will be able to finish the module 2 also in today's lecture. So we will be able to finish the entire syllabus for ISC in today's lecture, है ना. And the syllabus for ISC is module 1 and module 2. Okay, so I have shared the screen. Yes, can you see my screen?
Yes, sir.
Okay, so these are some extra problems also. Okay, तो ये तो हमने किया ही अभी. ये वाला प्रॉब्लम मशीन वेज है ना. फाइन. हाँ, नहीं नहीं, ये थोड़ा ये अलग प्रॉब्लम है, इसमें थोड़ा चेंजेस किए
नहीं
हैं
सर,
ऐसे.
डिफरेंट है, हाँ वही।
हाँ, ये डिफरेंट है ना. तो ये है ना, इसमें देखो ये वाला प्रॉब्लम सॉल्व करना. इसमें अपने को डिस्प्लेसमेंट और वेलोसिटी फाइंड करना है. डिस्प्लेसमेंट एंड वेलोसिटी ऑफ मास एज अ फंक्शन ऑफ टाइम. ओके, एंड डिस्प्लेसमेंट वेलोसिटी आफ्टर 0.4 सेकंड, है ना. तो ये प्रॉब्लम है, यही है ना. ये सब प्रॉब्लम्स है व्हीकल वाइब्रेशन इन सिंगल डिग्री ऑफ फ्रीडम सिस्टम. ओके, अब देखो ये भी एक प्रॉब्लम है ना. सो टू सम 2-3 प्रॉब्लम्स आर आल्सो देयर इन दिस शीट. ओके, तो ये शीट भी मैं आप लोगों के साथ शेयर कर दूंगा ये वाला. तो इसको भी सॉल्व करना, एंड इन केस ऑफ एनी डिफिकल्टी यू कैन आस्क. ओके, सो बाय टुमारो आफ्टरनून आई विल शेयर एवरीथिंग कंप्लीट इन ऑल रिस्पेक्ट फ्रॉम मॉड्यूल 1 एंड 2. सब मिल जाएगा आपको, एवरीथिंग, राइट. चलो अभी हम लोग विल मूव टू द मॉड्यूल 2. जस्ट गिव मी अ मिनट. Okay, so let's go ahead. Yes, can you see my screen properly?
यस सर।
Yes,
Okay,
sir.
okay, fine. Okay, so let's see. So basically, we have already discussed most of the concepts as far as the tire is concerned. Okay, now okay, so now we will focus on some specific part of this module, that is the tractive properties or of the tire, the cornering property of the tire, and the this the tire slip. Okay, so these concepts are very very important. Okay, in order to understand the tire mechanics well in detail. Okay, this is very very important one. Okay, so basically what happens, this tire slip is what? So tire tread is there in the front end, the contact patch. Okay, so tire tread will be there in the front and the contact patch. Okay, so due to this the compression will be there, and this compression will be responsible for the shear deformation of the side walls of the tire. Okay, so we know the distance that the tire travels will be less than the free rolling. And why it is so? Due to the longitudinal slip. Okay, why it happens? Due to longitudinal slip. Okay, now let's see how to calculate this slip mathematically. So this is the formula for calculating the longitudinal slip mathematically. Okay, I is equal to V minus R omega into 100. In this way, we can calculate this longitudinal slip in percentage. Okay, so V is equal to R omega. Okay, so V is equal to Re into omega. So V by omega is equal to Re. Okay, so in this way, I have written here. Okay, 1 minus Re divided by R into 100%. Okay, क्या हो गया? V is equal to Re into omega. So Re is equal to V by omega. So V by omega की जगह हम Re रख देंगे. 1 minus Re divided by R into 100. In this way, I can calculate longitudinal slip in percentage. Okay, so let's see what is the meaning of each symbol. So here V represents V is the linear speed of the tire center. What is omega? Omega is the angular speed of tire. What is R? R is the rolling radius of free rolling tire. And what is Re? This Re is the effective rolling radius of tire. Okay, so this is how we can calculate the longitudinal slip in percentage. Now we can see what happens when we apply the driving torque. When driving torque is applied, so what is the effect of this? Due to this, the tire rotates without equivalent translatory progression. Okay, remember this. Okay, this is a very important aspect of this tire mechanics. When we apply the driving torque, so the tire rotates without equivalent translatory progression. Okay, so basically we can say this R omega value, the product of R and omega will be greater than V, or simply we can say this V will be less than R omega. Okay, so we will get the positive value of slip. You can see, देख सकते हो ना आप? तो इन दिस वे देखो ये कैसा है, V अगर R ओमेगा से कम होगा तो हमें पॉजिटिव वैल्यू ऑफ स्लिप मिलेगा. कैसे? यू जस्ट सी द फॉर्मूला. V is less than R omega. Okay, तो यानी कि something less divided by bigger number, so I will get a number less than 1. So 1 minus a number less than 1, so that means I will get the I value, that is longitudinal slip value, as a positive number. Okay, so we'll get the positive value of slip. Now what happens when V is 0? Okay, जब V 0 होगा तब क्या होगा? Put the value here, V is 0. V अगर यहाँ पर 0 हो गया, that means I is equal to 100%, है ना? V is 0, so I is equal to 1 into 100, so that is 100%. Okay, so longitudinal slip will be 100%. And where I can see this 100% slip? On the icy surface, we can see this 100% slip. So this is the concept of tire slip, very, very important one. Okay. Now let's move. Chalo. So slip angle. Now we'll talk about the slip angle and the cornering force. I've already told you about this. The vehicle is moving on the road surface in some direction. That direction is known as x direction. Okay, and that is known as longitudinal direction. And the side direction is the y direction, that is known as lateral direction. Okay, and the z direction is the vertical direction. So along all these direction, the forces will be there. The forces will be there. That is the longitudinal force, lateral force, and the vertical or the normal force along x, y, and z axis respectively, or we can say along the longitudinal, lateral, and the normal direction respectively. Okay, and along these directions, the moment will also be there. So we know how to calculate these forces and the moments. How to calculate these forces and moments, and what will be the effect of these forces and moments, and how to minimize these forces and moments, that we have already seen. Okay, so I've already told you, if a vehicle is moving on the road surface in the x direction, that is the longitudinal direction, so the side force will act. Okay, that is lateral force will act. So due to the application of this lateral force, our vehicle will move in a direction other than the longitudinal direction. That means our vehicle will little bit tilt and it will move in a direction other than the longitudinal direction. So a tilt between the actual direction of travel and the longitudinal direction, that tilt is nothing but the slip angle. So what can I say? What is responsible for the slip angle? The lateral force is responsible for the slip angle. So if the lateral force is maximum, so slip angle will be maximum, and if the lateral force is zero, so slip angle is zero, and vice versa. Okay, so this we know. So basically, what is side slip? So side slip is the lateral. What do you mean by side slip? Side slip means the lateral elasticity of the tire. Okay, this we know very well. Okay, this we know very well. Fine. So you just see here. Here I have shown the forces. Okay, we are making the analysis of slip angle and the cornering force. So you just see here Fs forces, we have applied this Fs force is nothing but the lateral force at the contact patch. What is the contact patch? That means the patch or the spot where our tire surface is in contact with the road surface. So that patch or the spot is known as contact patch. So lateral force at the contact patch, that is Fs. Okay, so due to this, the tire move along a path at angle with the wheel plane. Okay, so you just see here, this is the longitudinal direction, and this is the actual direction of travel. A tilt is there. That tilt is nothing but an angle, so that angle is known as slip angle. Okay, so you just see here, that is there Fs and Fy alpha. Okay, that is the side slip. Okay, so side slip you can observe. Okay, so yeah, so basically we can uh, calculate it by getting the actual tire heading velocity. Okay, so this is the velocity we can calculate with the help of this graph, and this is Fy. Yeah. Okay, the force, direction of force, you can see. Okay, so this is the mechanism for the slip angle and the cornering force. Now we'll see. Okay, the very important concept, you can see what is this longitudinal lateral force at the various slip angles. This is a very important concept. Okay, the very important one. Okay, so you just see here, we are talking about the longitudinal and the lateral force at various slip angles. So we know the longitudinal force will act along the longitudinal direction, and the lateral force will act in the lateral direction, but in the side direction, and lateral force will be responsible for the slip angle. Okay, so you just see here. So what happens? The braking and accelerating will take place in the longitudinal direction. So that means the braking force and the accelerating force are nothing but the longitudinal forces. And what are the side forces? The cornering and cornering force and the side winds are the side forces. Okay, that is the lateral forces. Clear? Yes, Jidan? Hello? Yes, Bakar?
यस सर.
समझ में आ रहा है ना?
हाँ सर, हाँ सर.
है ना? देखो क्या है, longitudinal direction, lateral direction है. So longitudinal force will be there in the longitudinal direction or along the longitudinal direction, and the lateral force will be there along the lateral direction. And what is responsible for slip angle? Lateral force is responsible for slip angle. That means if the lateral force is 0, slip angle will be 0. If the lateral force is maximum, so our slip angle will be maximum, and vice versa. Okay, so you just see here. So what about the longitudinal force? We know we have divided our vehicle dynamics into three category. One is the longitudinal dynamics. Three directions are there. So our dynamics is classified into three category. That is the longitudinal dynamics, lateral dynamics, and the vertical dynamics. Okay. So aerodynamics comes under longitudinal dynamics, and this steering comes under lateral dynamics, and the suspension comes under vertical dynamics. Okay, so what happens, we will, when a vehicle is moving on the road surface, that means we are moving along the longitudinal direction. So brake, what do you mean by this braking force and this driving force or the accelerating force? So this that means these are acting along the longitudinal direction. So these braking and accelerating forces are nothing but the longitudinal forces. And what about the side forces? Okay, side forces means the cornering or the side winds. Side forces means the cornering and the side winds. So that will be the lateral forces. Okay, you can see here lateral force. So Fx represents the longitudinal force, Fy represents lateral force. Okay, so you can see here, so we have plotted the lateral force with respect to slip angle, and we have shown the relationship. Here the longitudinal force is there along the x direction, and lateral force is there along the y direction, and we have shown the plot of this lateral force for the various slip angle. Okay, so fine. So in reality what happens, you can see here, if my here driving force, okay, or accelerating force, that will be the positive force. That's why I've shown this along the positive x-axis or the positive x direction, and the braking force, that is a negative one. That's why I've shown this braking force along the negative x-axis or the negative longitudinal direction. Okay, so you can see our longitudinal force will be maximum when the lateral force is 0. You just see here this sketch. This is okay. So you can see with the longitudinal force will be maximum when the lateral force is 0, and you can see here points. You just see the points: point A, point B, and point C. So here at the point A, the braking force is maximum, and the braking force is nothing but the longitudinal force. Okay, and here B, the driving force is maximum. That means when the longitudinal force is maximum, so the lateral force will be 0. And at point C, the lateral force is maximum, so that means here the longitudinal force is 0. But you know, we know that in the reality, both the longitudinal and the lateral driving conditions will be there. Okay, so when we plot, when we show a variation of this lateral force with respect to the longitudinal force for the various slip angle, we will get this this type of sketch. You just see here alpha is equal to 1. यहाँ पर 1 degree slip angle है, so we got this. Alpha is equal to 2, slip angle is 2. Alpha is equal to 4, this is a slip angle 4. Alpha is equal to 6, slip angle is 6. Alpha is equal to 10, so slip angle value is 10. Okay, so we got these curves, you know, the orange one. These curves we have plotted the slip angle for the various lateral forces, है ना, lateral force y axis पे, तो various lateral forces के लिए हमने slip angle को mark कर लिया है. और ये जो extreme position है, एक्सट्रीम पोजीशन जो है ये स्लिप एंगल का, इधर से और इधर से, ओके, इससे टच करते हुए हमने एक कर्व ड्रॉ किया. वी हैव ड्रॉन अ कर्व टचिंग द एक्सट्रीम position of this slip angle. So we'll so we'll draw a curve. So we'll get a figure like this. So okay, so we'll get a circle type of figure. So that circle is known as friction circle. but actually we will not get actual circle. We will get a figure that will be similar to the ellipse. So sometimes it is also known as friction ellipse also. ठीक है, तो इसको हम इस स्केच को फ्रिक्शन सर्कल भी बोलते हैं और फ्रिक्शन इलिप्स भी बोलते हैं. ठीक है, एक सर्कुलर फिगर कर्व आता है, लेकिन ओके, तो इसलिए फ्रिक्शन सर्कल कहते हैं, लेकिन वो एक्चुअली एग्जैक्ट सर्कल नहीं होता है, उसका फिगर जो है वो थोड़ा इलिप्स जैसा रहता है, तो इसलिए इसको वी कॉल इट एज द फ्रिक्शन इलिप्स आल्सो. ओके, वो बोथ आर हैविंग सेम मीनिंग है ना, आइदर वी कॉल इट एज फ्रिक्शन सर्कल और फ्रिक्शन इलिप्स, बोथ आर हैविंग सेम मीनिंग. ओके, तो इस तरीके का अपने को ये फिगर मिलता है. हियर ये कर्व से हमने अभी एक ये ड्रॉ किया. व्हाट इज दिस एफ आर? दिस शोज द रिजल्टेंट फोर्स. Okay, so that means what can I comment when the maximum lateral force is there? Maximum lateral force C पर है, यहाँ पे longitudinal force 0 है, no longitudinal force is there. ठीक है, और maximum longitudinal force कहाँ पर है? A और B पर, तो यहाँ पर lateral force 0 है. You can see this. Okay, so very very important one. Okay, so we can what can we conclude? We can say, what is this friction circle or friction ellipse? As driving or braking force is added, the maximum resultant force that can be achieved is defined by the points lying on a curve that is known as friction circle or friction ellipse. Right? I'm again repeating this. What is this friction circle or friction ellipse? As driving or braking force is added, right? So the maximum resultant force that can be achieved is defined by the points lying on a curve that is known as friction circle or friction ellipse, right? So this is a very very important concept. Now let's move to the another one. Yes, most important concept, that is the tractive properties of the tire. Okay, tractive properties of the tire, the cornering properties of the tire, very very important one. Okay, बहुत important है tractive properties of the tire and show its variation with the longitudinal slip. Very very important question. So if we talk about the tractive properties of the tire, we know this is the mathematical expression for calculating the longitudinal slip in percentage. I is equal to V minus, I is equal to 1 minus V by R omega into 100. This is how we can calculate it in percentage. And V by omega is Re. So, okay, so the formula becomes 1 minus Re divided by R into 100. So this is a way to calculate the slip in percentage. Okay. So we know this tractive force will be directly proportional to the wheel torque applied. Okay, and this slip will be function of tractive effort. Okay, we know the slip will is the function of tractive effort, and tractive force is directly proportional to wheel torque applied. That means as the wheel torque increases, the tractive force also increases, and the slip is a function of tractive effort. Okay, so what is responsible for this initial value of slip? So the initially the slip is due to the elastic deformation of tire tread. Okay, that we have represented here in this sketch by OA. Okay, right. So basically, so this is very very important one. Discuss on the tractive properties of tires and show its variation with respect to slip. Sorry, with respect to longitudinal slip. Very important one. They discuss on the tractive properties of the tire and show its variation with longitudinal slip. Okay, so to show the variation with the longitudinal slip, we will draw a graph for the tractive effort with respect to longitudinal slip. So we have taken the longitudinal slip on the x-axis and the tractive effort on the y-axis. So you just see the figure. So we will get a curve like this. Okay, so initially the slip is due to the elastic deformation of tire tread, generally denoted by OA in this figure. Okay, so initially you can see, what can I comment about OA? This is OA is linear, so I can say initially the variation is linear. Okay, now it will again, if we further increase the longitudinal slip, so this tractive effort will also change and it will reach to the maximum value. Okay, and it will reach the point B, that means it will reach the maximum value. And after this, if we further increase the longitudinal slip, so this tractive effort will start decreasing and it will reach to a certain value. Okay, so you can say up to this OA. Okay, so we have represented this by mu pw by 2. And what about B? We have achieved the peak value. The peak value will be mu pw. And here the least value will be the sliding value, that is mu s into w. Okay, so where what is this? W is the normal load. And what is mu p? Mu p is the peak coefficient of road adhesion. And what is mu s? Mu s is the sliding coefficient of road adhesion. Okay, and what is this AB? What can I say about this AB? This AB is the tire tread sliding on ground, and it is linear on or non-linear. The relationship is non-linear. Remember this. Okay, so we can say this maximum tractive force will be 15 to 20% of slip. Okay, so this we can comment. Okay. Okay, right. So we'll move to the another one. Okay, so now it is 6:47. Okay, so since we started late, okay, so will conclude by 7:15. Chalo, okay. Yes, can you see my screen? The cornering properties of tire on your screen?
Yes, sir.
Okay, fine. Okay, so this is also very important concept, the cornering properties of the tire. Okay, so you just see, we can make the analysis for this. You just observe the figure. The figures are very, very important in order to express all this. So you just see for the cornering properties of the tire. Okay, so we have shown this the variation of this cornering force with respect to slip angle. Okay, and we have shown this cornering property of the tire for the various tires. Okay, if okay, so for the various tires like radial tire, this is a radial tire. The variation of this cornering force with respect to slip angle is this. And for a bi-ply tire, this is the variation. Okay, this is the variation. Okay, we have particularly selected a case of a two-wheeler, that is motorcycle. Okay, so here you can see this cornering force is directly proportional to slip angle approximately. So you can see as the slip angle increases, this cornering force is also increasing. But that this cornering force will be below the road adhesion limit. Okay, so here you can see alpha. We have used a symbol for the slip angle. And what is side slip? The lateral elasticity of the tire is responsible for the side slip. Okay, so side slip will be due to this lateral elasticity of the tire. Since we know the tire provides the primary source of suspension. Okay, now you can see here. Lateral force at tire ground contact patch. So the cornering force will be there, that is known as F Y alpha. Okay, so basically when the camber angle of wheel is equal to 0. Okay, so we'll get this. As the cornering force increases at a lower rate with increased value of slip angle. Okay, so we'll get when the camber angle of wheel will be equal to 0. Okay, now if we talk about this, so we can say that it reaches the maximum value. Okay, you just see here, increase हो रहा है, पहले तो linearly increase हो रहा है mostly यहाँ तक एक limit तक, जो कि around we can say अराउंड 6 डिग्री है ना, 5 और 5.5 डिग्री तक है, लीनियरली ऑलमोस्ट हो रहा है। उसके बाद फिर ये उसका इंक्रीज होना, थोड़ा इंक्रीज हो रहा है बट थोड़ा कांस्टेंट की रेंज में आ रहा है, स्लाइट इंक्रीजिंग है ना। उसके बाद बियॉन्ड 5.5 डिग्री, so reaches maximum value when tire begins sliding laterally. So if we talk about the passenger car, the maximum cornering force will get at slip angle value equal to 18 degree. And we talk about racing cars, so cornering force will get at approximately 6 degree. So we talk about this cornering stiffness, the C alpha, so that is nothing but dfy dfy alpha divided by d alpha. Okay, so this is the cornering coefficient. Okay, this is the cornering coefficient. Phi alpha is this cornering force, right? So when we differentiate this cornering force with respect to the alpha, we get this cornering stiffness, C alpha, or cornering coefficient. Okay. So cornering coefficient is what? The cornering coefficient, if we plot this cornering coefficient with respect to the percent nominal load, okay, we can see as the percent nominal load increases, this cornering coefficient decreases. So cornering stiffness per unit normal load. Okay, what is cornering coefficient? Cornering coefficient is nothing but the cornering stiffness per unit normal load. So this cornering coefficient decreases as normal load increases. Now let's talk about the inflation pressure plays vital role. So you can see for the inflation pressure, if we talk about the variation of this cornering coefficient with respect to the inflation pressure, okay, so we have shown this for the different types of tires. Okay, the first one is the radial tire, and the second one is the bias belted tire, and the third one is a bias tire. So you can see the family of curves. Okay, we'll get the variation for all the three types of tires. So you can see the family of curves because the pattern is almost same. Okay, so we can see as the inflation pressure increases, this cornering coefficient also increases. पहले ज्यादा इंक्रीज हो रहा है ना, पहले लीनियर है ऑलमोस्ट अप टू 24 है ना, 24 से थोड़ा कम 23 तक psi है ना, 24 psi सेक्शन प्रेशर तक ये ऑलमोस्ट लीनियर। उसके बाद फिर इंक्रीज तो होगा लेकिन थोड़ा सा मतलब बिल्कुल लीनियरली इंक्रीज नहीं होगा, है ना। You can see the variation. These graphs and these variations are very very important for the tire. Okay, now we'll talk about this. This next one is also very very important, most important one. Okay, the variation of this slip angle and the self-aligning torque. You can see this is our self-aligning torque. Okay, so these are for the various slip angle. We have shown the variation of this self-aligning torque. Okay, so this value we got 0 degree, 1 degree, 2 degree, 3, 4 degree, 8 degree, 12 degree, 16 degree, and you can see here. Okay, so for the different values of slip angle, we have shown the self-aligning torque for the different values of normal load. Okay, so this you can say this Fy alpha value and this Fs Fy value this force value Fy alpha at the ground plane and this force value Fs at the wheel center. These are not collinear forces. Okay. So due to this, the self-aligning torque will be there. So self-aligning torque, what is the observation here with the help of this graph? The self-aligning torque first increases as alpha increases. You can see, देखो alpha जैसे increase हो रहा है, पहले वो increase हो रहा है. Okay, and it reaches the maximum value. यहाँ पर वो maximum value तक पहुँच गया, ठीक है. अब इसके बाद क्या होगा? Now this self-aligning torque will start decreasing with further increase of this slip angle. So we can observe this. Okay. So basically, what is responsible for this? Mainly, it is caused by the sliding of tread in the trailing part of contact patch at the high value of slip angles, and due to this, what happens? This point of application of this cornering force will be shifted in the forward direction. Okay, this will shift the point of application of this cornering force in the forward direction. Okay, the point of application becomes very, very important. Okay, so what is this? Suppose if we are working on an engineering problem, so we talk about the force. Okay, so what is how what is this? So how can we specify any force completely? So four informations are required in order to specify any force completely. Force is a vector quantity, so the magnitude and direction is required. Now, where the location where our force is acting. So if our force is acting at a point, that means it is a point load. So it is well and good. Otherwise, if some different type of load is acting on a system, it can be uniformly distributed load or uniformly varying load or trapezoidal load or any simple varying load. So we have to convert that particular load into a point load, and point load is a load that will act at a particular point. So if I'm talking about a point load, that means the point of application becomes very, very important. And then the four, okay, so this third one is the point of application, and fourth one is what is the nature of the force, whether it is compressive force or the tensile force. For a tensile force, the two forces acting on a body will move away from each other, so that is known as tensile force. And if the two forces acting on a body are acting towards each other, so that is known as compressive force. Okay, so what is responsible? So what information is required to specify any force completely? Four parameters are required to specify any force completely. That is the magnitude, direction, point of application, and the nature. Now the camber and the camber thrust. Okay, we've talked about the camber also in the early when I started this the tire, and this camber, caster, toe in, toe out, kingpin inclination. Anyways, we are going to study all these things well in detail in module 4, that is steering. And this is a part of this steering geometry also. Okay, so camber and the camber thrust, you can see here. This is a camber, and when the value will be positive or negative, when we'll get positive camber, negative camber, or positive caster, negative caster, we'll see. So you just see here, what does this represent? This shows the theoretical center of rotation of the cambered wheel. And what is this? This is a kingpin offset. This is the offset. Okay, this is what positive camber, and what is this? This is a kingpin inclination. ठीक है, तो ये आप देख सकते हो, इतना ही ऑफसेट है. So camber, what is responsible for the lateral force at the contact patch? Okay, and how we are getting this lateral force? Help of this camber thrust, that is Fyy. So free rolling tire with the camber angle revolve out O point. Okay, so camber tire, so constrained to move in a straight line. So, okay, so basically due to this, a small camber torque will be generated. Okay, so the lateral force in the ground plane, okay, is there. So we can calculate total lateral force, the Fy alpha, the force at the contact patch, and this Fyy, that is a camber thrust. Okay, camber thrust, and the force at the contact patch. We'll add this, so we can calculate total lateral force. Okay, now we'll talk about this characterization of the cornering behavior of the tires. Okay, so basically what happens, here we have shown the different springs are there. So lateral springs are there, side walls are there. This is the wheel rim. Okay, so we have shown this different models are there. So this is a stretched spring model. Okay, based on the assumption that The tread of the tire is equivalent to a stretched string restrained by a lateral springs. That is representative of the side wall with the wheel rim that is acting on the base of the rims. Okay, so basically it shows the discontinuities of the slope of the equatorial line, and that is permissible here in this case. Okay, so what I have shown here, the first model is the stretched spring model. So what is the model uh, talks about? So basically, based on this assumption that the tread of the tire is equivalent to a stretched string restrained by lateral springs. Okay, that represents the sidewall with wheel rim acting on the base of the springs. So this is how we can express our tire model as a stretched spring model. So discontinue, but you can see discontinuities of the slope is there for a equatorial line, and that is permissible here. Now the next model is a beam or the elastic foundation model. So you can see here the continuous lateral elastic support is there. Okay. Now, what about this beam model? So tread is considered equivalent to an elastic beam with continuous lateral elastic support. Okay, so if we talk about this cornering behavior, the cornering behavior is due to the characteristic of the equatorial line. Okay, and so finally, where it is at the contact line. Okay, it is at the contact line. So basically, what do you mean by equatorial line? I'm talking about this equatorial line. So this equatorial line of tire is nothing but the intersection of undeformed tire tread with the wheel plane. ठीक है ना? तो equatorial line क्या होती है? What is equatorial line of the tire? The intersection of undeformed tire tread with wheel plane. ठीक है? Wheel plane के साथ जो undeformed tire tread का जो intersection रहता है, that line is known as equatorial line of tire. And this position of equatorial line in contact area is called contact line. Okay, fine.
Yes, sir.
And the position of equatorial line in contact area is called contact line. है ना? तो equatorial line भी हमें समझ में आई. Equatorial line is the intersection of undeformed tire tread with wheel plane. And what is contact line? The position of equatorial line in contact area is called contact line. So this the performance of the tire becomes very important as far as the different surfaces are concerned. That's why the tire testing is required, different tire test on the different road surfaces. So performance of the tire on the wet surface is one of the very important and crucial aspect. So what are the factors on which this performance of tire on the wet surface depends? So for the factors are the surface texture, water depth, tread pattern, tread depth, tread material, and the operating mode of tire. That is very important. Okay, that means operating mode of tire means whether it is free rolling or braking or accelerating or cornering. What is the operating mode of the tire? Okay, and what is the tire tread, whether the pattern is suitable or not. What about the hydroplaning? And hydroplaning and aquaplaning, it is very important. Okay, very important concept. Okay, when what is this? When a vehicle is moving on the road surface, so some quantity of water is there, है ना? अब कुछ तो टायर सरफेस उसको डिस्पर्स कर देता है, लेकिन अगर वाटर का जो वाटर कंटेंट अगर ज्यादा है रोड सरफेस पे, तो वो पूरी तरीके से डिस्पर्स नहीं कर पाएंगे. नंबर ऑफ प्रॉब्लम्स विल बी देयर. So we have explained, we have already discussed this hydroplaning and aquaplaning well in detail with the neat sketch and what will be its effect and how to minimize this. What is the best possible solution that we have already studied. So if we talk about the ride properties, it is very very important to study the ride properties of the tire in order to improve the the ride quality. So we need to make the analysis for the ride property of the tire for the static condition, for the non-rolling dynamic condition, and for the rolling dynamic condition. Okay, so that is required. Okay, now let's move again. Okay, now you can see the screen. Yes, can you see the screen?
Yes, sir.
Okay. Okay, so just see just see this, the influence of tire size. Okay, so influence of the tire parameters on the rolling resistance we will see. So what happens, this tire radius, these are the factors which are, these are dimension very very important. What is the tire radius, what is the width, okay, and what is the normal load, what is the velocity, okay, what is the inflation pressure. Okay, this becomes very very important. So tire deformation in the contact patch, this is very very important. And how much tire deformation is there in the contact patch, and what is the rotational aerodynamic drag of the wheel. Okay, and what is the slip between the tire and the road on wheel rim, that is also important. So influence of tire size that we see will see. So this tire deformation becomes very very important, and viscoelastic energy loss will be there in the tire. So you can see influence of the tire size. Okay, ये देखिए आप, rolling resistance coefficient of the tire with outer diameter at 2.1 bar. Okay, as per this ISO standard, ये इस तरीके का इसका वेरिएशन रहता है. तो रोलिंग रेजिस्टेंस कोफिशिएंट डिक्रीज हो रहा है एज द डायमीटर इंक्रीजेस. ओके, डिक्रीजिंग टाइप ऑफ बिहेवियर है. ये पैरामीटर्स पर अपने को फोकस करना है. टायर रेडियस, width, inflation pressure, normal load, and velocity, and these are the factors. Okay, now let's move. Now we can see the variation of this, the coefficient of this rolling resistance with respect to the tire diameter. अब देखो यहाँ पर रोड भी डिफरेंट डिफरेंट है. यहाँ पे कॉन्क्रीट रोड है, ये यहाँ पर medium hard soil road is having medium hard soil, and here on the road surface the sand is there. So different road conditions are there, and we have to show the coefficient of rolling resistance with respect to tire diameter. So as the tire diameter increases, है ना, ये जो coefficient of rolling resistance will decrease. अब देखो कंक्रीट के लिए ज्यादा चेंजेस नहीं, वो ऑलमोस्ट कांस्टेंट है, थोड़ा स्लाइट डिक्रीज हो रहा है, वेरी स्लाइट. मीडियम हार्ड सॉइल के लिए थोड़ा डिक्रीज हो रहा है, और ये सैंड के लिए काफी डिक्रीज हो रहा है. दिस वी कैन सी. देखो अभी रोलिंग रेजिस्टेंस की बात आ गई, तो रोलिंग रेजिस्टेंस किस पर डिपेंड करता है? रोलिंग कोफिशिएंट पर, है ना. और रोलिंग कोफिशिएंट किस पर डिपेंड करेगा? क्या चीज कांटेक्ट में है? टायर सरफेस और रोड सरफेस, यानी कि रोड क्वालिटी or the factors associated with the road surface, or the that means quality of the road surface, that means the factors associated with the road surface, and the quality of the tire surface, that is the factors associated with the tire surface. Okay, so we can see, observe this rolling resistance coefficient change with the tire diameter and the type of surface. Now here the rolling resistance coefficient variation we can see with the help of tire size, है ना. So more tire width will be there. Okay, if the more tire width is there, the less rolling resistance coefficient will be there. Okay. Now if we talk about the influence of tire inflation pressure, so you see the variation. So this shows the variation of coefficient of rolling resistance with respect to inflation pressure. देखो, और इसमें भी डिफरेंट रोड सरफेस, यहाँ पे कॉन्क्रीट सरफेस है, मीडियम हार्ड सॉइल है, यहाँ पर सैंड है. तो आप देख सकते हो, as we increase the inflation pressure, है ना, तो this coefficient of rolling resistance decreases. कंक्रीट के लिए स्लाइट डिक्रीज हो रहा है, मीडियम हार्ड सॉइल के लिए भी स्लाइट डिक्रीज हो रहा है, और सैंड के लिए काफी इंक्रीज हो रहा है. Okay, this shows the variation of rolling resistance coefficient with respect to inflation pressure of the tires at the for the different surfaces. So rolling resistance decreases as the inflation pressure increases, and the parameters will be constant. Okay, so we keep the parameters constant. If we increase the inflation pressure, so the this velocity deformation will decrease, and deformation of the rubber will be less than the tire with lower pressure. So that we can conclude on the basis of all this study. Now you can see the variation of this rolling resistance with respect to the pressure. So as the pressure increases, this rolling resistance coefficient decreases. You can see the value at the various major location on this graph itself. Okay. This lowered hysteresis losses, what is responsible for this? Hysteresis losses are there. So okay, so we can say at the higher inflation pressure, hysteresis losses will be uh, low. Okay, at the higher inflation pressure value, hysteresis losses will be low. Okay, we will get this variation like this. So as the pressure increases, this FRR or CRR value will decrease. That is rolling resistance coefficient will decrease. As per this is the variation given by this ISO 8767. Now the dependence, let's see the dependence of the rolling resistance on the inflation pressure for a particular type of tire we have selected, that is tested at this much value of pressure, okay, this much value of load, and at 60 mile per hour. So you can see as we increase the pressure, this rolling resistance decreases. Okay, and the pressure range is 1.1 to 4.4 bars. Now let's see the influence of normal load. Yes, see here the value of this FRR or CRR with respect to the normal load. Okay, so more bending and shearing will be there due to the increase in the normal load. So we can say as the normal load increases, the rolling deformation of the tire element will increase. So that means increase in the rolling moment will be there. So as the rolling moment increases, stresses damping, okay, compression will also increase, and due to this, the rolling resistance force will also increase. So this will get this variation. Now, if we talk about the rolling resistance variation with respect to simple load, so we can simply say as the load increases, rolling resistance will also increase. Very simple to understand and show. Now, you can see here the value of rolling resistance coefficient with respect to vertical force. Okay, so it depends on the type of tire. We can decide whether it will increase or decrease. Okay, we can not particularly comment on it. Basically, we need to know what is the type of tire. On the basis of this type of tire, we can comment that whether it will increase or decrease. Now, what is the influence of this longitudinal velocity? Okay, so we can see, we can show the variation of this coefficient of rolling resistance with respect to speed. Okay. For the different types of tires. Okay. So you can see the variation of the rolling resistance, variation of the coefficient of rolling resistance with respect to the longitudinal velocity or the speed for the different types of tires like radial tire, bias tire, and okay, and any other type of tire for the okay for the various car tires rated condition. So आप देख सकते हैं इधर रेडियल का उतना इंक्रीज नहीं हुआ रोलिंग रेजिस्टेंस, बाइस टायर का ज़्यादा इंक्रीज हो रहा है कोफिशिएंट ऑफ रोलिंग रेजिस्टेंस एज वी इंक्रीज द longitudinal velocity. This variation we got after n number of testing of the various tires. So this construction of the various tires become very important that we had studied at the start of this module. Now we can see here what is the variation of this FRR with respect to the speed. है So we have shown this for a passenger car. So you just see here the blue one. This shows the passenger car tire without a capped crown, and this the pink one. This shows the passenger car tire with a capped crown. So without capped crown और capped crown इसमें आप देख सकते हो 20 से लेकर के 100 तक है ना यहाँ पे. तो ये जो है ये ऑलमोस्ट कांस्टेंट रहेगा. उसके 100 के बाद से चेंजेस आते हैं. विद कैप्ड क्राउन में उतना ज्यादा इंक्रीज नहीं हो रहा है, विदाउट कैप्ड क्राउन में काफी ज्यादा इंक्रीज हो रहा है. इट्स द वेरिएशन ऑफ एफआरआर सीआरआर with respect to speed. Now this you just see here what is the variation of coefficient of rolling resistance with respect to velocity. अब देखो कैसा हो रहा है. ये red represents the stationary condition and the blue indicates the driving condition. So 1 से लेके 2 पर गया. ओके आप देख सकते हो वेलोसिटी डिक्रीज हो रहा है. उसके बाद फिर यहाँ पर 2 से लेके 3 पे गया है ना. उतना ही वेलोसिटी रख के अपना कोफिशिएंट ऑफ रोलिंग रेजिस्टेंस इंक्रीज हो गया. दिस द वेरिएशन एक्चुअली जो ड्राइविंग कंडीशन में से 1 to 2 2 to 3 और फिर स्टेशनरी कंडीशन अपने को डायरेक्टली ये इनिशियल पोजीशन और फाइनल पोजीशन लेकर के वी विल ड्रॉ अ कर्व, क्योंकि एक्चुअल नेचर हमें मालूम है कि as the velocity increases this coefficient of rolling resistance decreases. So on the basis of this standard nature we'll draw a curve which will pass through the initial position and the final position. तो इस तरह का कर्व मिल जाएगा आपको. Okay, so okay, just give me a minute. Okay, so let's talk about this tire vibration. So we can say on the basis of this we can represent this as a first mode, second mode and the third mode of the tire vibration. So first mode up to 60 hertz, second mode 90 hertz and third mode 110 hertz. Okay, so this represent the model resonance of a tire. So basically we can see the variation of this tire resonance, and we can see the transmissibility, tire resonances and the footprints. Okay, so this shows the tire resonance properties measured on a vehicle. So ultimately we can say the mass element and a spring, a linear spring in parallel with a viscous damping element. This is how we convert this system into mass spring system. And for this viscoelastic model, this viscous damping coefficient is required, dynamic stiffness of the tire is required. Okay, so that we can that is required to be calculated. Okay, from a well established theory of the free vibration of single degree of freedom system. So from this we can calculate the equivalent viscous damping coefficient. Okay, CEQ, that is equivalent value. Okay, CEQ, equivalent value of damping coefficient, and the dynamic spring stiffness, that is K, calculate कर लेंगे. A damped natural frequency of the tire with mass m can be identified from the amplitude decay trace that we can calculate. T क्या होता है? T is equal to, है ना, T is equal to 2 pi by omega d. यहाँ से हम ओमेगा डी कैलकुलेट कर लेंगे 2 pi by t. इस तरीके से वी कैन डू दिस. Okay, so okay, so we can see the variation for this this spectral density with respect to frequency for the radial and the bi-split tire. So almost the pattern is almost same. You can see little bit change, but we can identify the pattern. The spectra of the force is measured when a tire encounters an obstruction. So we have shown the variation of the spectral density with respect to frequency. Okay, so I will take 10 more minutes. Okay, now yes. Okay, now we'll talk about this conicity and the pliosphere. That is also very important concept of this tires. Okay, so you can see the for this conicity and this pliosphere. So you can see if we show the variation. So here the slip angle is there, and here the lateral force is there. So here we can show the that longitudinal forces, and here the lateral force. Here the slip angle is there. So if we move in the forward direction, and that is the reverse direction, this is our movement. So here you can see this cuts the y-axis here while going in forward direction, and while in the reverse direction, this movement cuts the y-axis here. So so this distance on the y-axis, जब forward में जा रहा है तो यहाँ पर cut कर रहा है ये distance, और जब reverse में आ रहा है तो जो y-axis का movement cut कर रहा है ये distance. This is what this is conicity. Okay, and okay, so this we have shown here the pliosphere also. So this we can represent on the basis of this slip angle. So lateral force behavior around zero slip angle. We have to see what is the behavior of this lateral force around the zero slip angle. So this the behavior of the tire and the zero lateral slip condition. Okay, nearly, okay, approximate value. So this is very important. Okay, so the refinement is required for this, for the high speed automobile. So for an ideal tire, the zero lateral force coincides with the zero slip angle. I've already told you when this what is responsible for slip angle. Lateral force is responsible for slip angle. So if the lateral force is maximum, so lateral slip angle will be maximum, and if the lateral force is zero, the slip angle will be zero. Okay, but for actual tires, this is not a true fact. Okay, this is for the ideal one. For actual tires, the behavior of the lateral force at a small slip angle will be similar to similar as shown in this figure here. In this plot, the lateral force is plotted as the tire is rolled in both the directions. And both the directions, the tire is rolled. Okay, that means here we have shown the tire is rolling in the forward and the reverse direction. The important observation is the lateral force behavior differs with the direction of rotation. Okay, it will be different in forward direction, will be different in the reverse direction, and offset will be there from the origin of the graph. Okay, offset will be there from the origin of the graph. Okay, so basically this tire accounting this behavior is the conicity in the construction. So conicity is nothing but the side to side differences in the tire, such as asymmetrical offset in the positioning of the belt. Okay, that's why the name is given. Okay, so the conicity has a character of being random in the direction, and it is dependent on the quality control in the tire construction, and this is how it can improve the tire performance and ultimately improves the uh, quality of the ride. Turning a tire on the rim will change the direction of the lateral force caused by the conicity. Okay. So basically rolling downward, the force will again be the right, but since the lateral axis of the tire is now pointed downward, so it is a negative lateral force. And so in this way, we can identify the direction. Now, the mechanism that will can be presented in a tire is a ply steer, which arises from the angle of the cords in the belt layers. Okay, so basically this ply steer concept arises from the angle of the cords in the belt layers. So to avoid this bias in the tires uh, rolling the direction, belts are constructed with alternating belt layers at the opposite angles. Okay, and perfect balance will but for this the perfect balance is required, so but perfect balance is impossible to achieve. So free rolling tire will have a tendency to drift from its direction of heading. Okay, this we have shown in the figure. Okay, so when rolling in one direction, it creates lateral force to the right. Okay, and this we can show in the tire axis system given by SI. Okay, when rolled in the opposite direction, okay, so it will exhibit a force to the right in the SI tire axis system. So when the tire lateral force properties are measured, where in the vicinity where the slip angle is nearly zero, so ply steer has a non-zero offset in the lateral force and averaged from both direction of travel. Okay, so basically we can say this ply steer is dependent on the tire design. Okay, nearly equal in magnitude and direction for all tires of common design. Okay, so basically we can say this both the conicity and the ply steer forces, the magnitude of these forces are dependent on the vertical load carried by the tire. Okay, so दोनों ही conicity और ply steer किस पर depend है? Load carried by the tire, and this conicity is more sensitive to inflation pressure, and it can be reduced by the adjustment in this pressure value. Okay, so this is having a relevant effect on the vehicle performance. Okay, so now we'll move to this performance on the tire wet road surface. Okay, after this I will conclude. Okay, this lecture. So this is very important. This the what is the performance of the tire on the wet surface? Okay, the hydroplaning is there. This I've already discussed well in detail. What is the performance of the tire on the road surface when the which is wet? Okay, so if the more amount of water is there, so it will be difficult for the tire surface to disperse all the water. So the problem like hydroplaning or the aquaplaning may arise. Okay, so this is we have already discussed well in detail in the previous lecture. कैसे क्या calculate करते हैं, है ना, वो सब भी है. So lift component of the hydrodynamic force is FH, so it is proportional to the ground contact area, fluid density, and square of the vehicle speed. So FH is directly proportional to this. Okay, this is rho F AV square, where rho F is the fluid density. That means whatever fluid is available, Okay, and FH is what? FH is the hydrodynamic force, and A is the area, and V is the velocity. So when the hydroplaning है ना, थोड़ा mathematical aspect में और देख लेते हैं. When the hydroplaning occurs, this lift component of this hydrodynamic force is equal to the vertical loading on the tire. So at the speed at which the hydroplaning begins, okay, that will be proportional to the square root of the normal ground contact pressure. Okay, so which is proportional to the inflation pressure of the tire. So ultimately we will get this expression. Vp is equal to 6.34 square root pi in kilometer per hour. So in this way we can calculate the speed, okay, in terms of the inflation pressure of the tire. ये देख सकते हैं आप, कंप्लीट हाइड्रोप्लानिंग है. ये देखो बिल्कुल स्टीयर हो जाएगा. वी आर स्टीयरिंग इन द एयर. ओके, रियर पार्ट और रियर साइड, फ्रंट साइड, दिस इज कॉन्टेक्ट एरिया. अब यहाँ पे देखो, यहाँ पे थोड़ा ज्यादा नजदीक है बी रीजन, तो ए में जैसे जैसे से आगे बढ़ता जा रहा है. अभी पार्शियल हाइड्रोप्लानिंग, तो यहाँ पर हुआ है हाइड्रोप्लानिंग इस एरिया तक, सी में नहीं है हाइड्रोप्लानिंग. ओके, तो वेरिएशन भी दिखा सकते हैं वेलोसिटी का हम. यू कैन सी द वेरिएशन of the peak values and the sliding values mu p and mu s, or the coefficient of road adhesion with the speed for a smooth tire. Okay, with a tire with rips and a tire with rips and the strips on the wet surface that we have shown in the graph. SM indicates a smooth surface, RBD is the ribbed surface, and SBD is the ribbed and stripped surface. इस तरीके से हमने दिखाया है, इस तरीके का है. Different surfaces. Right properties of the tire that I have already discussed, है ना. क्या क्या रहता है इसमें, कैसे कैलकुलेट कर सकते हैं ये मास स्प्रिंग सिस्टम में कैलकुलेट करके. फाइनली हम इक्विवेलेंट स्टिफनेस, इक्विवेलेंट डैम्पिंग कोफिशिएंट कैसे कैलकुलेट करेंगे, और दिस स्प्रिंग कांस्टेंट कैसे कैलकुलेट करेंगे. ये आप वेरिएशन भी देख सकते हो, ये मैंने अभी बताया था. ओमेगा डी कैसे कैलकुलेट, कैसे कैलकुलेट करेंगे, टी इज इक्वल टू 2 पाई बाय ओमेगा डी. सो ओमेगा डी वी कैन कैलकुलेट. और ये वेरिएशन है, देखो इस तरीके से डैम्पन हो रहा है वाइब्रेशन. So it's very simple. Omega d is a damped natural frequency of the tire with mass m and can be identified from the amplitude decay. Delta is the logarithmic decrement, है ना, logarithmic decrement है, and it is defined as the natural logarithmic of the ratio of two successive amplitudes x1 and x2. Natural log of x1 divided by x2, that is logarithmic decrement. इस तरीके का है, and finally the vibration will dampen. रोलिंग डायनेमिक स्टिफनेस, इसका वेरिएशन है स्टिफनेस का विद रिस्पेक्ट टू द इन्फ्लेशन प्रेशर. एज इन्फ्लेशन प्रेशर इंक्रीजेस, दिस विल बी द वेरिएशन ऑफ द स्टिफनेस, है ना. ये अभी हमने इतने सारे वेरिएशन देखे, तो उसमें ये भी वेरिएशन ऐड हो जाएगा. देखो ये तो हम देख ही चुके हैं ऑलरेडी. वेरिएशन, इन्फ्लेशन प्रेशर जैसे से इंक्रीज हो रहा है, डायनेमिक स्टिफनेस इज इंक्रीजिंग. फैमिली ऑफ वेरिएशन यू कैन सी. Variation of static stiffness with inflation pressure for a radial plied tire is shown here in this figure, and we have taken a particular case of car. Variation of this inflation pressure on the rolling dynamic stiffness here we have shown in this figure. Now the magic formula of for the tire model, that is very very important question. So basically on the different testing method, we have obtained an empirical method for characterizing the tire behavior that is used to fit the experimental tire data that we got after the n number of experimentation, that is required for characterizing the relationship between the cornering force and the slip angle, self-aligning torque and the slip angle, or the braking effort and the skid. Okay, relationship you can see, and the behavior. Cornering force and slip angle, number one. Self-aligning torque and the slip angle, and or we can say the braking effort and the skid. So it is expressed by this expression, y-axis is equal to this expression. Y-axis is equal, capital Y-axis is equal to small y-x plus SV. We can represent small x is equal to capital X plus SH, where y-x represents the cornering force, self-aligning torque or braking effort, and this capital X denotes the slip angle or skid, and okay, B is called the stiffness factor, C is the shape factor, D is the, anyway, here in this expression, D is the peak factor, and E represents this curvature factor, and SH and SV are the horizontal shift and the vertical shift respectively. Okay, so we can make the interpretation of this equation. The first equation produces a curve that passes through the origin, and when the origin is there, so x value will be equal to 0 and the y value will be equal to 0. It will reach a maximum value at x is equal to xm, that we have shown in this figure, this figure 0 है, फिर कैसे मैक्सिमम वैल्यू हो रहा है, देखो ये इंक्रीज हो रहा है स्लिप एंगल के साथ, साइड फोर्स का वेरिएशन ऑफ साइड फोर्स विद रिस्पेक्ट टू स्लिप एंगल, as the slip angle increase side force is also increasing. देखो पहले वो linearly increase हो रहा है, उसके बाद फिर slight increase होगा, almost constant हो जाएगा, और सभी टाइप के टायर्स के लिए ऐसा ही है ना, और ऑलमोस्ट पैटर्न ऐसी रहेगा डिफरेंट फोर्सेस के लिए. पहला वाला दिखा रहा है आपको 8 किलो न्यूटन के लिए, फिर सेकंड वाला 6 किलो न्यूटन के लिए, थर्ड वाला 4 किलो न्यूटन के लिए, फोर्थ वाला आपका दिखा रहा है 2 किलो न्यूटन के लिए. यू कैन सी द पैटर्न. X and Y value will be 0. To allow the curve to have an offset with respect to the origin, two shifts will be there, SH and SY. Okay, so new set of coordinates we can get, capital X and Y, that will represent the cornering force, self-aligning torque, and or braking effort, and slip angle or skid. These values we can establish. Okay, so this enables the effect of ply steer, conicity, or the rolling resistance, or the cornering force, self-aligning torque, or the braking effort to be taken into account. Okay, this is the importance of this tire magic formula. This figure illustrates all this information. Okay, magic formula is capable of producing characteristics that closely match the measured data. We can see the graph that shows the variation, or that basically the comparison of the measured and fitted values using this formula. So now we can see the comparison, the slip angle, the self-aligning torque variation with respect to slip angle for the various forces, and 2 increase करते जा रहे हैं, 8 kilonewton, 6 kilonewton, 4 kilonewton, 2 kilonewton. Okay, this we have done after the testing, experimentation testing, and data collected, and then we have calculated these results. This is the variation. Estimation of the tire road friction. Okay, Fx, Fy, and Fz are the longitudinal, lateral, and the normal force on a tire. So normalized traction force of the tire we can calculate by this expression. Square root Fx square plus Fy square divided by Fz. If we consider only longitudinal motion, so assume that lateral force Fy is neglected, so Fy value will be 0. The square root of Fx square, so Fx only. So rho will be equal to, normalized traction force will be equal to Fx by Fz. Now, how can you determine the longitudinal force? So here we have shown a bicycle model, bicycle type model. Here we have shown. So we have neglected this the road gradient and this and wind speed here. So as per the longitudinal dynamics, we will get this expression. Here this is the model. You can see here. This is what? This is a point where the whole mass of the, or where the whole mass or the whole weight of this car will act. Okay, this is mg. Okay, now what is this? This is our front wheel, this is our rear wheel, front wheel and the rear wheel. Now the distance between the center of the front wheel and the center of gravity, let us represent this by LF, and the distance between this center of gravity and the center of the rear wheel is LR. Okay, reaction will act at the contact surface of this front wheel and front tire surface and the road surface. This is ZF, and the reaction that will act at the contact point of this rear tire surface and the road surface, that is FZR. अब देखो मोशन किस डायरेक्शन में, लॉन्गिट्यूडनल डायरेक्शन, दिस इज डायरेक्शन ऑफ मोशन, तो रेजिस्टेंस विल एक्ट इन द डायरेक्शन अपोजिट टू द डायरेक्शन ऑफ मोशन. तो है ना, तो ये आप देख सकते हो. तो रेजिस्टेंस आर एक्सएफ रियल फ्रंट व्हील पर रिएक्शन लग रहा है अपोजिट टू दिस, एंड आर एक्स आर ये भी रिएक्शन लग रहा है अपोजिट टू दिस डायरेक्शन, है ना। तो हमने यहाँ पर ये फोर्स एक्ट करवाया है एफ ए, तो यहाँ पर आप देखते हैं रियर व्हील में और फ्रंट व्हील में ये फोर्स इसके अपोजिट लग रहा है। एंड व्हाट इज दिस, एच इज द हाइट। ओके, दिस इज व्हाट सेंटर ऑफ ग्रेविटी का हाइट है फ्रॉम द रोड सरफेस, दिस इज स्मॉल एच। ओके, ये ए एक्स acceleration. So you can get what is the total mass of the vehicle. M is the total mass of the vehicle. AX is the longitudinal acceleration or deceleration. FXF and FXR are the front and the rear wheel traction or the braking forces. RX is what? है ना, x डायरेक्शन में रिएक्शन टोटल क्या होगा? रिएक्शन acting reaction for acting in the x direction for front wheel and the reaction acting in the x direction for rear wheel, इन दोनों को ऐड कर देंगे तो टोटल रिएक्शन x डायरेक्शन मिल जाएगा। Okay, that is the rolling resistance force with the roll coefficient being the rolling resistance coefficient. dA is what? Aerodynamic drag force constant. Vx is the longitudinal velocity. This is all about in this expression. We are talking about this expression. Okay, so LF is the distance from the center of gravity to the front axle. LR is the distance from center of gravity to the rear axle. So L क्या हो जाएगा? L ये total है. Total L is what? LF plus LR is L. That means center to center distance. Distance between the center of the front wheel and the center of the rear wheel. Okay. By the wheelbase of the vehicle, the total longitudinal tire force Fx, this we can calculate with the help of this expression. Fx is equal to Fx F plus Fxr. So max mod में ax है, ax will be positive plus rx will be positive. da vx square इसका भी मॉड लिया, ये पॉजिटिव। ये कब होगा? जब एक्सेलरेशन वैल्यू इज ग्रेटर देन इक्वल टू 0, यानी एक्सेलरेशन के केस में। और ये एक्सप्रेशन हो जाएगा जब x इज लेस देन 0 डीएक्सेलरेशन केस में। Once the vehicle longitudinal acceleration deceleration is measured by using accelerometer and corrected for the bias, the total vehicle longitudinal force fx can be calculated. ये सब वैल्यू मान लेंगे हम लोग, टोटल fx कैलकुलेट कर सकते हैं। ओके, डिटर्मिनेशन ऑफ द नॉर्मल फोर्स, लास्ट वन। तो zf में z डायरेक्शन में जो फोर्स है वो कैसे कैलकुलेट कर सकते हैं? दिस इज द मैथमेटिकल एक्सप्रेशन फॉर कैलकुलेटिंग द नॉर्मल फोर्स एट द फ्रंट व्हील, and this is the expression for calculating the normal force at the rear wheel. Okay, so weight of the vehicle, this contributes the major part of this normal force. So longitudinal acceleration deceleration forces acting on the vehicle, okay, this will be responsible for the redistribution for this normal forces between the tires. So if a vehicle is traveling on the straight road surface, so normal force at the front and rear tires can be calculated with the help of these expressions. Okay, so acceleration of the vehicle causes the normal forces on the front tires to decrease and the normal forces on the rear tires to increase. Okay, this is the way we can calculate. So if mu is equal to 1, so maximum longitudinal force generated can be as much as the normal force Fz, and this will happen at the optimum value of slip ratio. Okay, and if the mu is less than 1, so maximum longitudinal force that can be generated only due to the friction of this normal force Fz. Okay, so this is how we can make the analysis for. We can calculate the normal force for the front wheel, normal force for the rear wheel, and in fact we can do some experimentation. Okay, we can make the analysis. Okay, so I will stop here. So this is so we have completed the second module, also complete in all respect.